hello everyone. I want to talk about debugging, and basically it's debugging with QEMU. I work in the Institute for System Programming, and our team had a bunch of emulator-related projects. Part of this work was upstreamed as a record-replay subsystem for emulation. We also have not upstreamed, but open source subprojects for instrumentation and WinDbg stub. In WinDbg, this subprojects are published on the GitHub. WinDbg stealth debugging means that the debugger connects to the emulator without switching the system to the debug mode, so you can even replay its behavior and debug with the WinDbg. We also have reverse debugging or time travel debugging patches for GDB that are supported by GDB protocol. So we will send these patches to the mailing list soon, and probably QEMU will have reverse debugging capabilities. I want to speak about system-wide debugging, its approaches and its problems. Basically, when people use system-wide debugging, and they use hypervisors and emulators to debug system code or malware to isolate it, or in case of QEMU, we can use execution recording to reproduce hidden bugs. Or another big thing is cross-platform debugging, which allows to use many platforms except x86. Normally, debugger user wants the debugger to provide many services, and when you run WinDbg, you can have all this information about the system. You can examine processes, you can switch between them, set breakpoints for them, you can see the symbol names of the functions. But this approach, of course, it is Windows only, and it also requires requires the debug mode of the operating system. In case of GDB, these things are a little bit harder to use, because when you're a developer, you can run gdbserver inside your virtual machine, or you can attach to the kernel and load its debug symbols into the debugger. But when you're a reverser, sometimes you don't have these capabilities. Sometimes you can't even get the debugging symbols. For example, when the core is pre-built, when the kernel is pre-built, for some platform, the kernel could have some changes. You don't have SDK for that, so you can't figure out the symbols. You can try, if you're a Jedi, I know. So the GDB couldn't show you anything but list of the instructions and memory contents. It can't detect which processes are running, you can't set breakpoints on the specific processes, except for the case if you're a Jedi, you can figure out the process ID and specify the CR3 value in the breakpoint. But for the normal debugging case, it is not convenient. The problem of capturing the information about processes usually solved by virtual machine introspection, which which can extract this information required for full system debugging. And also another problem which occurs when you're trying to debug full system is that GDB still can't explore the processes even if you can extract them. There are several approaches to introspection. The first one is embedded the guest code, which reads required information from the system requested from the kernel or something like that. This is similar to running GDB or WinDbg server inside the machine. This approach is rather good, but it can't be used when, for example, you have a some custom kernel without SDK to build a guest agent, and you also can't record the execution of the system because this guest agent works within the system, and it also will be recorded. Another popular approach is analysis of the dumps with the forensic memory analysis tools. I say dumps, but in most cases, the dumps may be captured in runtime from the virtual machine. And you can observe the system-wide information, system-specific information in the debugger. But this approach is too slow for runtime events, so you can usually observe the system only when it's stopped. And of course, it requires some kernel information to pass the dumps. Another similar but more lightweight approach is event hooking. For example, you hook at process switching and then go through the list of the processes in the kernel. It is this approach is more lightweight than the previous one, but it still requires some knowledge about kernel. We also have some a little bit different approach in our SWOT repository on GitHub. It hooks only system calls and extracts information about running loaded executables and dynamic libraries. But it also doesn't require tuning for the specific kernel, but it still have limited capabilities because we don't know details of the kernel. For example, list of cannot iterate through the list of the processes because this approach is kernel doesn't configure it for the specific kernel build. The project which uses introspection for the debugging is Python mydebug project. It's intended to support. It's intended to provide operation system and debugger agnostic interface to support every hypervisor and every debugger. This project is still evolving. It supports only part of the hypervisors and debug protocols. However, it uses libvmi, and it seems that it's possible to implement WinDbg and GDB stubs for the virtual machines that already support libvmi interface. However, libvmi doesn't still supports QEMU, and for the best debugging experience, we also have to do some instrumenting. I think that instrumenting is required because we can't examine the call stack of the thread when there is no debug confirmation and when the frame pointer is omitted by the compiler. Then the stack, then the call stack contents is the only sequence of bytes. We can't even detect the return address in this case automatically. We could intercept calling and returning functions operations with stack pointer, but libvmi doesn't allow this, and this is primarily because it is impossible with hardware hypervisors. But it is okay for QEMU. That is why I think that QEMU is the best choice for debugging. Another two less meaningful things that breakpoints used by GDB protocol are too simple. They, for example, when you set breakpoint in the inner loop, you have the stop emulator every time you meet the address and check the condition within the debugger. We have proof of concept implementation of emulator side breakpoint conditions to check check these conditions within the emulator and make debugging faster. Another possible improvements of breakpoints include breakpointing the I/O operations, watch points for the larger memory areas than 4 bytes. For example, for watch point in the whole arrays. And of course, breakpoint in specific processes, but it can be solved by conditions. When you trying to extend or create new virtual device within the QEMU, you have to explore its its internal state, but usually you just run the debugger of the guest program and get some logs from the virtual device. So this is kind of inconvenient because you have to match the logs and the debugging of the guest. So it would be more handy to provide some information from the device to the debugger and make it observable for the user. The conclusion is that if you want system-wide debugging, you should use Windows. or you should do anything to create a new system-wide debugger which supports instrumentation, and it's probably should be based on QEMU because it is the only cross-platform debugger, cross-platform emulator. Thank you.
If there are no questions, thank you.